Pentec provides leading-edge board and system-level solutions for the most demanding requirements in data acquisition, digital signal processing, and software radio applications through excellence and innovation.
Today we're going to be taking a closer look at the Pentec Model 71662. In its native form factor, it's an XMC module, but it's also available in 3U and 6U compact PCI, as a PCIe board, as well as a 53662, which is available as a commercial or fully rugged VPX module, perfect for harsh environments. At its core, the 53662 is a 4-channel, 200 MHz, 16-bit A to D board equipped with a Vertex 6 FPGA, 2 GB of DDR3 synchronous DRAM, or optionally 32 MB of QDR2+ SRAM, has an onboard timing generator with multi-board synchronization capabilities, and an industry-standard Gen 2 PCIe interface. Another key feature of the 53662 are the built-in digital down converters. Each acquisition module contains an 8-channel multi-band DDC for a total of 32 individual tunable down converter channels. The DDC core in each module has a decimation range from 16 to over 8,000. And its decimating filters can accept user-supplied coefficients to fine-tune the core to your specific application. With 32 channels and a wide output bandwidth range, the 53662 cores are ideal for radar applications as well as many wireless communications applications from telecom to signal intelligence. While the 53662's FPGA can be an excellent platform for running user-created processing and data manipulation functions, many of the most common data acquisition functions are pre-programmed from the factory. Powered by 4 A to D acquisition IP modules in the FPGA, the 53662's built-in features include data tagging with channel ID, sample-accurate time stamping and data length and transfer information, data buffering and transit capture using the 4 banks of DDR synchronous DRAM memory. Each channel has a sophisticated chaining DMA engine that allows complex acquisition sequences to be easily configured, and an acquisition gate-driven DMA mode that allows all data captures and transfers to be dynamically controlled by the front panel gate input. This mode is especially useful for applications like radar, where the exact length of the gate is not known or is likely to vary. Regardless of how many features a board has, signal quality is still a key requirement. You can typically find the best possible performance specifications on a silicon manufacturer's datasheet. In this case, the datasheet for the Texas Instruments ADC 5485 converter used on the 53662 shows an SFDR of 88 dBc. Pentec's careful attention to PCB layout and overall product design allows us to maintain the converter's excellent performance on the 53662. Another challenge when designing systems is managing heat and power. This requires additional attention in smaller, tightly spaced systems used in harsh environments. The Cobalt family addresses this with 6 onboard voltmeters for monitoring all critical supplies and 11 onboard temperature sensors located in strategic positions throughout the board. These monitors are ideal for evaluating system-level cooling and can be integrated into an application control panel for easy operator access. Cobalt boards support user-programmable alarm thresholds, so if a chassis fan or other system-level component should fail, the board can generate an interrupt to the system computer in addition to lighting a front panel LED indicator. Beyond board features and performance, ease of use is another feature that differentiates the Cobalt family. A flexible onboard timing generator can supply the sample clock from a user-programmable VCXO, requiring no external clocking signals. The 53662 can also receive a full-rate sample clock from an external clock source. If an application requires locking to a system timing signal, the 53662 can receive a 5 or 10 MHz sample clock for clocking the VCXO. This is ideal for synchronizing the sample clock in multi-board systems. In addition, all boards in the Cobalt family provide a front panel timing connector for distributing timing signals across multiple boards. A ribbon cable is used to distribute clock, gate, trigger, PPS, and sync signals, making large multi-board systems easy to build. Here, 2 of the 53662 3U VPX boards create an 8-channel phase-coherent acquisition system. Many applications can be satisfied with the built-in IP functions, where no FPGA IP development is required. But for many applications, the Cobalt module is an ideal platform for custom processing IP development and deployment. Pentec has developed the GateFlow FPGA design kit for just this purpose. Designed to work with the Xilinx ISE design suite, GateFlow supplies all of the built-in functions as IP modules with VHDL source and test benches. GateFlow creates a user application container where all interface signals to the module are fully defined and documented. The factory-installed acquisition modules are created in this space. Partitioned this way, your custom IP can reuse any of the Pentec IP or replace some or all of the factory-installed functions as your application requires. Pentec's ReadyFlow board support package provides the software development component to the Cobalt family. Delivered as a high-level C language library, ReadyFlow contains all the routines for board configuration and operation. Available for Windows, Linux, and VxWorks operating systems, ReadyFlow libraries are fully documented with C source code provided. ReadyFlow requires no runtime license and a single seat can be used for multiple projects. The ReadyFlow BSP includes many application examples that can be used as tutorials or as a foundation for your application. ReadyFlow also includes pre-compiled examples that can be started through a command line interface. Simply enter the command with parameters for which channels to enable, the number of data sets to acquire, and a destination for the data, and the board will begin operating. Data can be sent to a file, to another application, or to the included ReadyFlow signal analyzer, where it can be displayed and measured in both time and frequency domains. With the command line interface and the signal analyzer, you can be up and running within minutes of opening the box and without writing any code. The 53662 is an ideal fit for a wide range of applications. With an input bandwidth from 300 kHz to 700 MHz, the board is suitable for direct connections to IF and RF ports of communications and radar systems. The Vertex 6 can handle real-time DSP tasks, such as demodulation and decoding. The 32-channel DDC satisfies applications where a multitude of channels need to be intercepted and received in parallel. In its full rugged and conduction-cooled configuration, it's an excellent match for high-altitude UAVs and harsh environments. The 53662 is available in a variety of different form factors, from XMC to 3U and 6U compact PCI to VPX and PCIe. Available in versions suitable for commercial to full rugged and conduction-cooled applications, development can be started in a desktop PC and then moved to deployment in the harshest environments. Multi-board synchronization, system-level monitoring functions, and built-in board features simplify your system design. With ReadyFlow BSPs, your application can be developed on Windows, Linux, or VxWorks platforms. And if your application requires the development of custom FPGA processing, the GateFlow FPGA Development Kit provides a fully documented and tested foundation to build on. All Cobalt modules can be configured with memory and FPGA densities that match your specific requirements. All Cobalt boards are provided with lifetime support via email, knowledge base, and direct phone access, helping ensure your ultimate success.
Contact Pentec for price and delivery and for application design ideas.